All right, welcome to today's explainer. Let's jump right into this. Because today we're looking at something so universally recognized, we literally never stop to question it. Seriously, if you've ever cracked open a desktop computer or, looked at the back of a TV remote or even seen a picture of the inside of your smartphone, you've seen it. That flat, complex miniature city of circuits and chips. And almost without fail, the foundation of that little city? It's bright green. It is the absolute undisputed standard of motherboard design. But why? With all the incredible, mind-blowing advancements in technology over the years, why are we still staring at the exact same shade of green we saw decades ago?
Is kind of a fun question to ask, right? Like, does the green color actually make a computer run faster? I mean, we naturally associate specific colors with performance in other parts of our lives. You see a bright red sports car, and boom, you instantly think speed. So it's totally natural to wonder if this specific, ubiquitous shade of green was picked by early tech pioneers because, I don't know, it conducts electricity better, or maybe it magically supercharges the processing power of the machine. Is there some secret performance boost hiding in that green dye? Well, to figure that out, we actually need to understand what it is we're looking at.
Okay, so here is the real plot twist, the true identity of that green surface. You aren't actually looking at the raw board itself. Nope. What you're seeing is a highly specialized coating. In the engineering world, this is called a solder mask. And honestly, this definition completely changes how we need to think about motherboards. The green isn't the fiberglass material of the board, and it definitely isn't the copper of the circuits. It's a deliberately applied protective layer that sits right on top of those intricate microscopic pathways. And the job of that solder mask is absolutely crucial. It defends the circuit against three massive enemies of electronics: dust, moisture, and short circuits. Just think about it for a second. The inside of a computer case is basically a giant dust magnet. Without this protective mask, all those nasty particles would settle right onto the raw electrical pathways. Add in just a tiny bit of ambient moisture from the air, and you've got a total recipe for disaster. The mask literally seals those delicate circuits away from the elements. But even more importantly, it prevents short circuits by making sure the solder, the metal used to glue components down, only sticks to the exact right spots. It stops it from accidentally bridging two pathways that definitely shouldn't be talking to each other. So it's a shield. But that still leaves our main question: why on earth is the shield green?
Well, that brings us to Section 1, the 3 benefits of green. Let's look at exactly why the industry picked this color. The answer actually boils down to 3 really practical engineering realities. First up, green is incredibly cost-effective to produce. When you're manufacturing millions, actually, scratch that, billions of circuit boards all over the world, the economic efficiency of your materials is everything. Over time, green simply became the cheapest, most reliable standard to churn out at scale. Secondly, circuit faults are super easily visible to engineers. Those tiny, intricate copper pathways, they stand out brilliantly against a dark green background. This high contrast means that when a quality inspector is hunting for a microscopic flaw, like a tiny break in the line, the green gives them the perfect backdrop to make those errors pop right out. And third, it reduces eye strain during crazy long working hours. Engineers spend all day staring at these boards through magnifying lenses. Green is universally recognized as a softer, much more relaxing color for the human eye to process for long stretches. It really helps prevent visual fatigue. So it was this perfect storm of cheap production, high visual contrast, and ergonomic comfort that cemented green as the ultimate industry standard. But things are changing. Let's move to Section 2, the new gaming trend, and how aesthetics are clashing with utility.
So the modern landscape of tech is actually a bit split. On one hand, we have our standard green boards, which still absolutely dominate with the highest global usage. I mean, from basic school laptops to massive enterprise servers, green is still everywhere. But on the other hand, we have this fascinating evolution of gaming boards. If you look at high-end custom PCs today, you're going to see motherboards in sleek black, pristine white, aggressive red, and even cool blue. For gamers and PC building enthusiasts, the internal look of the computer has become a massive aesthetic choice. They want the inside to look just as cool as the outside. Yet, even with this flashy new trend taking over the gaming niche, the vast majority of the world's electronics are still relying entirely on that trusty classic green. So let's bring it all back to our original mystery to wrap things up. The final takeaway here is pretty clear. The green color is chosen for low cost and easy inspection, absolutely not for power or speed. So the next time you're looking at a circuit board, you'll know for sure that you aren't looking at some magical performance-enhancing color. No way, you are looking at a brilliant piece of practical engineering. A surprisingly simple solution designed to keep manufacturing cheap, make the board super easy to inspect, and protect the workers' eyes. It's literally efficiency at its absolute finest.
Which leaves me with a little thought I want you to ponder today. If the green motherboard is purely about cost, contrast, and eye strain, what other everyday tech colors are hiding a secret engineering purpose? Like, take a look around your desk right now. Why is your Wi-Fi router that specific color? Why are most internal cables the colors they are? There is almost always a practical engineering secret hiding right there in plain sight. So keep looking closely at the tech around you, and hey, don't forget to follow for more fascinating deep dives just like this explainer. Catch you next time.